All right, so this is picking back up with our 6.2 notes on page 3. We just talked about the 3 different ways to find area under the Z curve, to the left, to the right, and in between, 2 delimiting values. The combination of things could look like the area either to the left of negative 1.7 or to the right of 1.23. First thing I would do is sketch this with 0 in the middle. Negative 1.87 would be down to the left of 0 with positive 1.23 somewhere up above. And either to the left, so that's going to be this region right here. Simple enough, we just look at negative 1.87 on our chart. Negative 1.87 is 0.307. For that area. And then to the right of 1.23, we have to look it up. Yeah. So we'll have to do 1 minus that since it's to the right. So that's going to equal 0.1093. I just add those two together.
I think it does get used the more you do it.
Yeah.
Did you just find on the chart 1.23?
I did.
Okay.
And I found 0.8907, or Bryce did. And then I subtracted that from 1.
Okay, that makes sense.
Yay! So add the 0.307 and the 0.1093, and I get 0.14 for the combination of those 2 regions. I've got some extra examples built in here. I think we start to get the idea after a while, so I'm going to skip part B, but I'll come back around if you have more questions. Example 9 is just the visual image of the questions we've asked previously in words. So find the shaded region for each standard normal curve. Here, you'll find the area to the left of each one and subtract, right? Just like we did in part C above. Part B does have a trick. Since we have a normal curve that's symmetric about 0, and we have the positive and negative of this value, all I have to do is find one of them and double it, because it's the same area. So I'm going to find negative 1.55 on my chart. Negative 1.55 is 0.0606. So since that's 0.0606, this is also going to be 0.0606. And that means my total area is just 2 times 0.0606, which is 0.1212. Not if it's symmetric like this. You've got this mirror image of your z-score. However, if you look at C, there are 2 ways to do that, but it's just as easy, just as simple to take and find both of these areas to the left of and subtract. So do this one as normal. Example 10. Toby, will you read that one for us, please?
Find the area under the standard normal curve that lies between the specified z-score. Sketch a standard normal curve and achieve the area of interest.
Great, thanks. So this one seems maybe a little out of place, but it has a purpose. So if I'm looking to sketch it, 0 in the middle, negative 1 and 1, and I'm talking about this region here, I find the area to the left of negative 1, which happens to be 0.8413. I find the area to the left of 1. I'm sorry, I did that backwards, didn't I? The area to the left of positive 1 would be 0.8413. The area to the left of negative 1 would be 0.1587. And if I subtract those two, I get 0.6826, which is equal to 68.26%. So this right here is 68.26%. Why does that look familiar? Yeah. The empirical rule, right? From Unit 3, 68%. The empirical rule within one standard deviation. What percent of the data would we expect to find within 2 standard deviations of the?
75. Oh, I remember that.
95, good. The 68, 95, and then if we go out 3 standard deviations, 99.7, good.
How'd you get the number? How'd you get .84?
I looked up -1 in the chart.
Oh,
That's it, -1 and 1. So 0.1587 and positive 1 is 0.8413. So 99.7. So I'm saying you should expect to find close to, between -2 and 2, we should expect to find close to 95%. There's going to be some additional decimals afterwards. And same for 99.7%. When you look up -3 and 3 on the table and then subtract. So it's kind of neat when you get to dig a little deeper into some of the rules that we just tell you this is what it is, and now you get to kind of see where it comes from. It's always nice in math. On the back, we have just 3 examples. I'm going to skip this part right here. However, Z sub alpha notation, it's not a strong leap from what we've been doing. You're fully capable of doing it. It's beyond what we have time for today. So example 11. We're talking these last 3 examples about finding the z-score for a specified area. Given the area, we're finding the z-score. So we're just doing a reverse of what we've been doing. In this first one, it says, find the z-score such that the area under the standard normal curve to the left is 0.84. The area is 0.84. My reference point is that if I were to draw this line and think about it, if my area is less than 0.5, I would draw my z-score arbitrary marking to the left of 0. If it's more than 0.5, like we have here, 0.84, I'm going to draw my arbitrary z-score to the right, because this area is greater than 0.5. This area is 0.84. Excuse me. Thanks. This also tells me that my z-score is positive, so I know I'm on the right side if I just go to the positive z-score side, and now I get to do a little scavenger hunt and try and find 0.84. I'm going to erase some of these markings here. 0.84. There's a bunch of 8.4s, right? There's mainly 4. So I want the closest one to 0.840, which would be this one right here. You see that? So you kind of have to allow for that in your own mind. It's not going to be exact a lot of the times. You have to find the thing closest. So then we go over and up, and we see that the z-score associated with this area is 1.0. So z, this z right here is going to equal 1.0.
Oh, that's a Z. I don't know, it was a 2.
It's a z.
Roughly the same shape.
There, that's why I draw a little marking, because I know my z's and 2's look alike. All right, example 12, use a standard normal distribution table to obtain the z-score that has an area of 0.999 to its right. So in this case, if I'm thinking about 0.999 area to the right, it's got to be, this z-score is over here of 0.999 of the area is to its right, leaving us with, on the left side, which is what I need to find in order to use this chart, I need to do 1 minus 0.999, which is 0.001 to the left. This z-score is clearly to the left of 0. It's negative, so I'm going to use my negative side of my z-score table and find 0.001. 0.001. Everybody find it?
No.
Look on your yellow table. Point.
Those would be
.001 I found. Look on the negative side.
Oh, I'm looking at the positive.
Right? Because we knew. That's why the sketch can help remind you, like, okay, this is on the negative. You did? What's the value of z? What?
0.4960. Negative 2.99.
What is it? Negative 3.09.
Negative 3.09. Yep.
Yeah.
No, I said that. It's not 3, it's 2. Negative 2.99.
Okay, so there's an exact .001. So occasionally it does happen that we get the exact area. So negative 3 point, actually it goes with 3 different values. You could say negative 3.0809 or negative 3.11. So there is a little bit of margin for error built into MathXL when you do your assignment. I'm going to go with negative 3.09. That was the first one that you all said. That was.
Not me. I knew I was bad. Use my eyes.
Hey, Bryce.
Contacts.
Chill, Bryce.
Oh, there it is. And then the last one we're talking about is between two z-scores. We would find, I'm going to call those z sub 1 and z sub 2. We would expect to find 0.35. That's the area here. It also tells us that the area to the outsides of the z-scores is 0.325. So if the default for my table is area to the left of, I'm just going to go ahead and find the 0.325 on my table, the area 0.325. I'll have this, and that'll give me this z-score. 0.325, you can see this z-score is below 0, so I'm going to find the negative side. Oh, there it is. 0.325. Somewhere between these two, I would say this one might be a little closer. 0.3264 is the closest one. So I'm going to go with a z-score of negative 0.45. So z sub 1 is going to be negative 0.45. And it's symmetric, right? We have the same area to the left of z sub 1 as we have to the right of z sub 2. It kind of reminds you of this previous question. You're just going to have the negative and the positive. So then my z sub 2 would just be a positive 0.45. Ta-da! That concludes our notes for today. Don't forget to like and subscribe.
Hit those bell notifications.
That's right.